And we're live with day 11 of Advent of Code. Today's problem is looks easy compared to the others. Today's problem requires us to look through this grid and operate with a very simple algorithm. The algorithm is look at every L, and if every surrounding element is empty, then it becomes occupied. If it's occupied, but there are more than 4 adjacent seats occupied, then becomes empty. Otherwise, it stays the same, right? So we need to get through this logic, which is if 4 or more are occupied, become occupied, otherwise become empty. Sorry, the other way. If 4 or more are occupied, become empty, and otherwise become occupied. Well, otherwise don't change. And dots are the floor doesn't change. So let's start with, so I've implemented parsing already because the parsing is always the boring part. And I have a board type, which defines the state of the board. I'm not sure if lists are what we want. Maybe we want vectors, but I don't think it would be too hard to change. So first of all, let's implement the logic here. So the logic is update tile, right? So update tile takes a tile and it takes a list of surrounding tiles and it returns the new tile, right? So it's not compiling list of tile. So if we are occupied, so the field is actually occupied. Oh, wait. Occupied, I'm gonna replace field by floor. Floor. Yes. And so L is empty, and this is floor. Compile, excellent. So if we're looking at floor, we're gonna stay floor. If we're looking at empty, then if all equal if all is 3, then empty becomes occupied, else it stays empty. Right, now we need to implement is free, right? So is free is this function takes a tile and returns boolean, and if it's floor, it's true. If it's empty, it's true. If it's occupied, it's false, right? And if it's occupied, what we need to do is I'm going to do our trustee count. We need to have this in the standard library, by the way. Ec a of list a of bool of mat, and this is a to bool, and it's not gonna be happy because of this, but this is simply length of filter math. And here we do if count equal occupied of xs is higher or equal than 4, then empty. I'm gonna call it free, else occupied. I'm gonna call empty free, empty free, Just because empty makes me think of floor, whereas floor is just floor. And it is not working for two reasons. Filter isn't imported, so import data.list. And tile is not an eq, so we need to do eq tile where A equal B. We need to pattern match on this. We get floor, 3, and occupied. Those are all true. Fantastic. So the logic is all here, right? If they're all free, then it becomes occupied. Otherwise, it's free. If it's occupied and the surroundings have more than 4 occupied, then we become free. Cool. So to solve this, we need to go through the boards and map with the surrounding tiles. I think for this we need to use indices, right? We have to go through every index of the list and check the surrounding tiles, right? That's annoying. So our thing is indexed by row and column, board and list of tile. Fantastic. And this is get chords, row col net of board of maybe tile. Yeah, so this is get row of. You can't infer A to A. Oh, that's a shame. But the thing is, when you say A to A, is this some unification to that? Yeah. If you just have the term lambda A to A, the problem is you don't know at which level you're at, but you can assume you're at level 0. Or because lambda A to A could be a type constructor that takes a type and returns the type. Well, I guess that works too, as ID. It's just type 1 to type 1, yeah. Yeah, but then you have to be polymorphic over the level. Whatever, I don't know. I don't actually know. So get row is, we need to get the index, right? So let's go through GitHub, address lang, again, address 2. Let's go into lib and base. You can infer type A to, yes, you can do that, yes. That's much easier to infer. Ah, the paper assumes types and type, okay. That's fine, like the universe levels are not, like, it's an implementation detail. Do I have index? Index. There is no index prime. Let's call it, is there data listed extra? Lib contrib data list extra. No, there isn't. Okay. So m index takes a net, takes a list of A, and returns m of maybe of A. What is this? Why does it not compile? It's unhappy about parentheses. Line 38. Ah. It's unhappy about this actually. Yes, so this is m index of row of XS, and this is m index of call of get row. This is nothing. This is just X. This is nothing. And this is m index k XS. Cool. Now we also need to do two things. We need to do subtract right, because we might, so this is subtract the right from the left. So if here we get 0 and 0, we return just 0. This is nothing. This is S of K. Oh well. This is just N. And this is subtract K and J. Okay, so get adjacent. What we do is we have a position in the board. So S row, call row, subtract 1 from row, call then there is S row, S call, then there is subtract row, oops, subtract call 1, yes, and now there is, let me do this at the next line. Now there is row and S call, and row and call, subtract 1. And we're missing 2, right? So those are the lateral ones, those are the vertical ones. This is this diagonal, now we need this diagonal. So now we need S row and subtract call 1 and subtract row 1 and S call. Right, and those are just like here, here, here. There must be a smarter way of generating this, right? There must be a better way of generating those pairs. Here, row, here this. So I have my list of indices. Now I need to get, so those are the indices. Now I need to get adjacent tiles. So those are get chords of, right, I need another helper. I need so many helpers. This is traverse, get chords of indices. Just gonna do flatten the thing here. So let's do this. Flatten of indices. Get chord is uncurry gets chord of excess. I'm gonna call it board. Board. Oops. Cat map. XS. It's not what I wanted, but it doesn't matter. Cat maybes. This is the one I want. XS. So this is a function from list to list. So this is map. Fantastic. And this is just pair of F and G. And a pair. Oh, is it not pair? Is it tuple? Yeah, I think what I remember makes sense. That is, they don't have the eliminator for pairs. Are you kidding me? They don't have an eliminator for pairs. Oh. Base data. There is no pair. There's D pair. D pair doesn't have an eliminator either. And this is A to C and B to C. Just do it. There we go. Oh, it's incorrect. how did he come up with this? Wait, how does this even compile? I remember why this doesn't work. Okay. I guess this is bimap then. Oh, it's not bimap. Let's just do this thing. X, Y goes to question mark. Okay. Does this work now? Board. Mismatch between lists of lists and tiles. Is it because I need to do this? No. Uncurry get chords. Is it uncurry lip get chords board? It's not. Wait, it's uncurry get chords flip board. Isn't it? Oops. Yes. It's so convoluted. So we have a list of adjacent tiles. It's not traverse. This is... What is traverse? Wait, is it traverse? It's not traverse. This is cat. This is concat map, right? No, this is map. This is cat maybes of map. Cool. And now we take our... now we just return it. Okay. Fantastic. So this gets us the adjacent tiles. And now what we need to do is... there's one more thing. So solving it. So if we look at the problem again, we're looking for a fixed point, right? So what we're gonna do is partial. We're gonna fix, and we're gonna define a fixed point as being fixed, not as in create a fixed point, but find, like, return the value that is fixed. And for this, what we're going to do is we're gonna do, so this is old value, and we're gonna do new value is f of old, and if old value is equal to new value, then return, doesn't matter which, else fix f of new value. And so this cannot be proven to terminate, right? Because this might just loop forever. You don't know. Does it compile? Yeah. So now what we need to do, so this will be partial. So the solution is to find a fixed point. Let found fixed. And this is fixed of We need to update the state of the game, right? So we're gonna call this play game, right? So this is a function from board to board. This is just fix play game of board. And once we found the fixed, what we're going to do is count equal occupied of concat found fixed. Fantastic. So now we just need to play our game. And so this will be simply map of where is it? Of update tile. No, we need to we need to iterate over the width and the height. So board doesn't have a width and a height. Guess I can just give it an argument, right? And here I will do, oops, width height. So this is row is 0 to height, and col is 0 to width. And now I need to go through both. Guess I can just do a monad comprehension, right? Yeah, let's do that. So this is update tile. So this is update tile of the tile is get chord that's annoying. Actually, what I want to do is map through it with the index, right? Map through each element with its index. So let's do just this update tile, and those are get adjacent. Get adjacent of I and J and board. Board. And I comes from 0 to 0 to height, and J goes through this. That's not what I want. I want... Okay. Like, ideally I want this, right? IJ tile. And I want to map this, right? And here I have a function, zip index board, right? And zip index. Oh shit, it's really unhappy about this. IJ tile. Play game. When unifying lists of... Yeah, I don't need any of these anymore. There we go. So this would be the list of nat, and file. Look at the type. No, that's not working. When unifying nat and nat, get adjacent. Well, processing right-hand side of play game when unifying nat and nat. Nat and nat. Mismatch between nat and nat. This is correct, isn't it? Is it unhappy because this is the same thing as this? No. Okay, what about this though? Does this work? Well, processing right side of play game when unifying tile and list tile. Update tile, get adjacent. Get adjacent and update tile. Update tile. Where's update tile? Takes a tile and a list of. So update tile takes a list. Undefined name tile. So confusing. Okay. So this will complain that it cannot infer the type of the argument, which is fair. But then why can't it infer this? Zip with index. Does this work? Zip with index. Oops. I don't understand why This doesn't work. Ah, I understand why it doesn't work anymore. Okay. Because board is not a list. So this is map of I to map of J. Right? J and tile of something. Oops. Wait, so that's giving an index. Want to be given an index and a row, right? I'm confusing myself. I think I need the row here, right? Index map. Index map. Can Idris figure this one out? I am confused. Why is this not working? Let's just do this. Let's just do the. This is list of nat, and row is a list of tile. So this is I and row. Oh, I see what was wrong. Oh, too late. I and row. And this is the same thing. This is J and tile. And this is update tile of get adjacent of ij of board. Cool. And this is a function from the row. Yes. And this is simply zip with index. Oops, this is simply a list of A to list of nat and A. So this is zip with index, and this does not compile. Why? Because there's no map here. Cool. And this is zip with index of board. Fantastic. And so zip with index is just zip of 0. 0 to length xs and xs. Is this it? Are we done? This is so much work though. I can't believe normal people did that. I don't think you're supposed to do it this way. Address 2, day 11. We need to get, let's get this. Let's get the test inputs. And now let's try to get it on the test inputs. 11. Solution is 37. Cool, it works. So download input 11.txt and try this. Oh geez, it's slow. Ah, there we go. I'm guessing getting the list of adjacent things is slow. Okay,